ZeroLINC is a tool for classifying incident reports. The architecture is like this. The tickets enter, then it passes to a normalizer that removes this hash from the anonymized entities. Then it passes to a router. The router sees if there are reference set, like this one that is already classified. You can use as a reference set to put in this embedding space so that the next incidents can use these clusters to classify themselves. If there is a reference set, and if there are incidents on this reference set that cosine similarity is more than 75%, it passes to an instance memory engine that you use the Queen tree embedding with 0.6 billion parameters, 600 million. That uses a KNN, k nearest neighbors, to vote and classify this ticket. Like this, you have the embedding space of the tickets, and you use and you classify in the 3 nearest neighbors. If there isn't tickets of close to this one that we are classifying now, it uses a fallback that passes to a zero-shot engine. There is two models, Glide class, that is the default, and the Berta and Ally. The Berta and Ally is more precise than Glide class, but is 7 times slower. So the Glide class is the default one. It has a verbalizer with the 12 categories and 8 verbalization sets. The prediction, then the output is predictions.csv. That is the tickets.csv that entered. That appended to them are 3 columns: the category of each incident, the confidence of each prediction, and the engine used. I will now run the program to show it working. The first one is to install the packages, use UV as a package manager. Now you run the test. The expected result is it passes with the 7 tests with no errors. As you can see, this is the expected result. Now I will classify the ticket sample that I showed, this one, and I will use the engine zero-shot max. There is the Bertan Ally that is 7 times lower than the other one. As you can see, it saved the predictions. Here, these 2 are right and these 2 are right. Only the middle one is wrong. That is another cat 12, not a cat 2. Now we will train an index. I will use these tickets that are already classified as a memory, a label, a reference set to this instance memory engine, and it will output the model. Now I will be classifying the same tickets using the model that I saved with the engine KNN. As you can see, it did a little bit of overfitting because in these 5 tickets there was 2 cat 12, so the many of them have 2 nearest neighbors that are cat 12, since the other ones have only one example. but we got 3 out of 5 right. That is the cat 9, cat 12, and another cat 12. Here it was a cat 5 and a cat 3. Now I will be running the auto mode. This auto mode, it decides for each ticket which engine it will use. As you can see, the chosen for each of these small reference set, it was cat 12. So it was K and N, K closest, K nearest neighbors. So the output was exactly the last one. Now we have another example with the auto mode. That is my tickets. That is another small reference set. This one is synthetic. This one, all of them are right. Cat 12, cat 7, cat 2. As you can see, antivirus, phishing, fail login attempts. So this one, all of them are right. And this was ZeroLINC.